basically what I'm going to show here is the application designer, but we did a captioning of the network designer to see how the network designer sees the services being built. So actually the first picture here is a picture of what we call application services. And we created these services. So I'm talking about HTTP, HTTPS, MySQL. You know, this is a library of services that the QA team can create, but they could share it with the development team. This is at enterprise level, right? The enterprise admin, they have tables of services and ports and how they communicate, what are the rules. We basically automate that, so they just need to click on what service they need to instantiate, okay? So this is basically application services, and in this example, DNS was not created part of that. So basically, the enterprise admin goes and adds DNS in the central table. DNS service goes and puts the destination port for DNS in there. And, you know, we can assign also like a DSCP code point for a specific application, like a quality of service indicator, right? And this is the basic networking domain creation. This is the regular network designer, right? So using a template, the networking guy will say, hey, I want a new instance for development team, okay? It says create, and right away, basically, a networking domain, which is a set of virtual routers and forwarders, VRF, IPVPN entities, are created for that particular development domain. This is a designer step, okay? Then next, basically, we are going to onboard those shared services for the development domain, okay? So we create first the shared services, so DNS, Puppet, and management. So you will see here, basically, we selected development domain, that routed domain. And basically, from here, we create a tier, which basically automatically gets an IP pool, a private IP pool. And we are adding it into the development domain, okay? Development domain, and then we tell the designer what service is allowed for this Puppet communication. So it's the Puppet service that we edit for this particular tier. So right now the domain has Puppet service attached to the template. Next, we are going to add the DNS. It will be a new application tier. And we allow everybody in the domain to talk DNS to these servers. Okay? You'll see here, we add the domain, we pull down an arrow, and in there basically we say allow DNS service to this particular set of servers. This set of servers are empty entities at this point in time. There is no compute. This is a pre-compute instantiation. So we do the same for management. Now for the management tier, you will see we are going to allow SSH and Telnet to everybody in the domain, because people need to access you know, the servers in the domain. So Telnet and SSH. And right now, basically, right now we are going to the final stage where we actually create a template for an application, and it's a website that we are going to design, okay? So this website will access all of these three onboarded services, DNS, Puppet, and management, okay? Will be able to be accessed and access those services. So, as I said, we are going to create a three-tier application that we are going to call website in the development domain. So, you will see, first step is to create the front-end tier. Okay? Every time we do the creation, the IP pool is assigned in there from our range. And you will see the business logic that we assign to it. Finally, there will be a third tier, which we are going to call database, right? Now we are going to go between tiers and tell each of them how they are allowed to communicate. So the front end, the web servers will communicate to business logic using JBoss. Business logic will communicate to database using MySQL. Now we have to expose this app to the internet. So we're going to use an internet macro in there. And from the internet macro, we will allow access into the server using HTTP and HTTPS. So the design is there, it's in place. And there is one thing I wanted to, okay, so right now basically we assign also, if you noticed, we assign from the floating IP pool, public IP addresses. So we are implementing also floating IP, which is a NAT capability for the front-end servers. So they can be accessed over the internet, okay? So the server got all of that. Now the template is in place. There is no compute assigned to it. It's just ready to go, okay? And notice here, the active VMs is 0, okay? We don't have any virtual machines instantiated to execute those functions at this point in time. So now the next step will be to go in OpenStack, in Nova, and run commands in OpenStack to instantiate the VMs, push them down into the server, and then our agents will tell our brain that the VMs got instantiated and will map them to these application tiers based on whatever you create in there, okay? We'll map them to the tiers. Now what we did to make the demo smooth, we actually have a button that creates the VMs and sends them to the Nova, okay? Sends the commands to the Nova. And then I will go in OpenStack and show you basically what got instantiated from a networking perspective as well. So actually, we don't have a look in OpenStack, we'll just use our VSD to be easier to track what's happening. So basically, we go here and we say instantiate an HTTP server. We put a flavor of virtual machine and we set 2 instances. Instantiate 2 instances and we instantiate them into the front end. Okay? You see here, our VSD interface discovered automatically the virtual machines. As they were instantiated, as they booted, they became green. Just follow that as we instantiate also the JBoss. So same thing here, we say JBoss servers. We'll put here 3 instances. Create. Here you will see them popping up. So they will boot, this one booted. All 3 of them will be instantiated, will have IP addresses assigned to them from the pool. Okay? And finally, we will put a MySQL virtual machine, okay, to execute the database function. Same thing will happen. And you'll see it booting it up. Now, before we go in OpenStack, we are going to go in our virtual machine list in there, and we'll look at the web servers first. So what I want you to, okay, let me just, what did I do? Okay, I think I pushed this by mistake in the wrong direction.
So why not just have
So we'll just go one more time through the database instantiation. I moved the cursor by mistake.
Spacebar starts and then stops.
No, but it moved back in time, so that's why. But basically the MySQL VM will boot. And now we are going to show you guys here the VMs were activated here. So this is one web server. And in the web server here, you can see there were IP addresses assigned. There is a public IP address. I hope you guys can see it here. And there is a 42.1, which is a private IP address for that server. And we're going to show you guys the policy rules that control what services can access from the internet and from the shared onboarded services, this web server. So basically here there will be quality of service. We didn't assign anything here. But you will see a number of rules that control all of these services. There is one that blocks everything and allows just those. And basically there are egress services as well allowed. Okay? And now you see here the public IP address assigned for internet access. So now this is a OpenStack view. So now we moved into OpenStack Horizon interface UI. You can see here there were like 6 VMs created, 3 JBoss, 2 servers, and SQL VM created in OpenStack automatically. And we're going to show you the networking that got associated for that particular application, the website. So this is an HTTP server that we selected. You can see here the private IP address, remember, was 47.2. We are going to select the networking part. So you can see basically what got created in there. So basically here you can see the business logic database and front-end grouping, policy grouping that got instantiated on the as subnets into OpenStack. So you see, we wanted to build this to actually help the customers make use of the SDN networking components. And this was one of the main reasons we got selected in a number of private cloud accounts. The comment we got very often was, even before we did this, they said, you got in here, we gave you a specific set of application requirements. You got them done and demoed in a POC in a few days. Previous SDN competitors did it in weeks. It took them weeks to go through all the Puppet manipulation they had. They had hardwire SDN. It was very hard to adapt from whatever design way of thinking they had into the new way of thinking customer wanted. This allowed them to actually manipulate the network primitives.
We have to be careful when we use the word puppet describing the one that...
It's not a puppet. Yeah, I was thinking about that.
I get thrown off because I'm like, why? It's pretty easy to do in Puppet. I don't know what the problem is.
Yeah, no, I was thinking about that, but I couldn't come up with an easier... definitely, marionette.
There
marionette.
We go. I like that.
That's an Italian kind of word, so I wasn't sure how well known is in US.
Do you have a virtual instance that folks can use? I know some other SDN companies offer that, where it's more like the CLI to be able to test it out and test CLI work, but is there an instance where folks can actually pull down and test out what at least the UI process and what the programmability looks like?
You mean from a REST API perspective?
Yeah, well, for your actual SDN OS, like is there a virtual controller that we can test out without...
Whether we offer it publicly?
Yeah.
Okay. Well, I mean...
Beta, maybe.
No. So, I mean, you see, once you get access to a VSD interface, right? We have basically, you can open a window and see in there all the REST API calls we are doing for the UI.
Yeah, no, but we're not yet currently offering...
We have it internally, but we didn't open it up, if that's what...
No, but they're asking if they can just, get an instance of VSP somewhere in the cloud. Not yet currently.
Play with it,
yeah.
you mean?
Right, yeah.
Yeah.
No, the closest is this OVH service software, which
will be opening for more customers in a couple of weeks. It's a private beta for the moment.
Yeah,
yes.
Yeah. Now, you see, on the other hand, I read a very interesting blog from Mark Burgess, the CF Engine founder. He was talking about, he was talking in general about cloud industry, right? And focus on building surgery tools, okay? We build surgery tools. Everybody started with that. Give people the possibility to, do surgery on whatever they want in there. He said basically the main problem that we should focus on solving is to produce basically pills, because most of the users of the enterprise admins, they don't need surgery. They need a pill when they have a headache, and they should be able to produce fast different type of pills. I think what are we showing here actually really is providing the production line for pills, right? And that's, I think, what's missing. If you think about how all the SDN started, was about how do you do surgery on specific flows. We can offer flow visibility. We have also a generic policy framework which allow people to actually run their own scripts next to the OVS, right? But I think the main problem, and what's actually make or break company success in this market, it's how easy it is to actually integrate and use the SDN solution from an enterprise admin perspective. And I think that's our main focus for the rest of this year and in 2015.
Do you do a standard syslog output or output to like a SIM tool?
Yeah, we do have basically analytics module. I didn't talk about that in VSD. We have an analytics module that consolidates on a per VM basis all the basically stats, and we can go down to 1 second interval on a per VM basis. And in general, all our internal processes, the VRS agents, the VSC, the VSD, they generate syslogs to a centralized server.
How about from an auditing standpoint? Like if you want to have, one of the challenges in this field is your auditor is more used to looking at a physical topology, and they want to go through the configurations of those devices. So how do you show that easily?
No, so we have in VSD, we have what we call a VSD console, which actually exposes every individual component from VRS, VSC, and VSD, and tells you basically what they are running in there, on which compute they are running, which server is handling them. That's one part to this answer. And in general, basically, I mean, if you're talking about stats, gathering stats, we have this stat structure in VSD, which generates basically an analytics set of reports. And then every controller, actually, if you look at the controller and the agents in the forwarding plane, behaves like a networking node. So there is a set of summarized stats that is generated by the controller for consumption by the networking guys. So think about it. It's a huge database, analytics database with REST APIs where you can go and access it. And we have in the UI TCA stats and everything exposed in there from this, where you can access the analytics database to build your own set of reports, right? And then there is the summarized set of reports that the controller exposes for the networking guys. And it could be a nodal level. We have a full set of routing information base, layer 2 information that is exposed as well. And we are tracking also what's happening in the underlay. So the controller actually talks to the underlay and correlates with failures in the underlay, the whole routing in the service overlay.
I guess what I'm trying to say is, like, if you're under compliance, like, you have to show your entire network topology on paper or Visio or something, and then you have to walk through every rule for every entity with Auditor. So, like, if this is changing daily, is there an easy way to export that? So then they can walk through a topology, look at all the rules between devices, what ports are open. Yeah,
so the way we design our security rules is there is a network map that can be shown and can be, you know, it's quite graphical, so that's relatively easy to export. And then the rules, it's a single rule set that applies to the whole network topology. So you can export all those set of rules, which sometimes are a bit abstract. They will refer to particular, you know, zones or names or policy groups, what we call policy groups, instead of, you know, specific IP addresses or subnets. But all of that complete rule set will be visible. Like, it will say, you know, from the database zone to the web zone, you will be able to see, you know, we're opening this port, and, you know, reflexive or non-reflexive, and so on.
You see, so, what's happening. So there is what we call, we have, because the controllers talks the regular protocols from a management perspective, we have basically in our service-aware management view that we inherited from Alcatel-Lucent, we have a full exposure of the topology and relationship between controller, underlay topology, and actually virtual machines attached to different VRSs. That's a networking view. And then, I mean, here we are showing the graphical representation of the rules. So what I show you was an abstract representation where you say web servers talk to, you know, business logic talk to database this way. But in reality, when this stuff gets instantiated, we also have a full set of rules that we keep inside with priorities assigned in there. So we have a full representation of the policy rules that actually got instantiated in the network. And we are basically representing them in UI by just calling the REST API. So somebody could basically take snapshots and do, comparison of the rules for policy compliance reason.
And I mean, all of this is, yes, is accessible through the REST API or as a list, and then we could do, you know, you could potentially do diffs every week or something like that to see if there's, you know, what has been opened or so on.
Right.
You see, what's happening here is nobody does basically step-by-step design of policy instances. There is basically an abstract representation of what needs to happen, and all of this is done automatically by the policy system, the instantiation, and then we keep track of it.
Where do you do your authorization and authentication? Is it just using native Keystone? Please say no.
Currently, no. We have our own local user database, and then we can sync to LDAP servers.
Okay. LDAP, do you have specific work that's been done on Active Directory? Because that's kind of like the de facto standard in a lot of folks.
Yeah, so we're extending to add support for Active Directory groups and so on. Currently, it's pure authentication, but we will support the importing of groups and referencing of groups to
like a role-based access and whatnot.
You see, VSD was built from the beginning with certain multi-tenancy representation. So there is a top layer for a cloud service provider, a wholesale provider. There are enterprise groups of users. Inside enterprise, you have the possibility to have subgroups, development, QA, and production. And inside, you basically can have other groups represented in there, and you have the users as leaves. You have super users like the enterprise admin, the wholesale provider representation in there. So it doesn't, I mean, we see people going around Keystone and using their own authentication system and calling us directly.
It's always a challenge because we're creating an amazing way to do programmatically deploy services, controls, ACLs, and then the first thing you have to do is you have to manually add a user in order to do it.
So no, we're adding support for LDAP. The thing is, originally we were the way the product was targeted was really for this kind of like cloud service providers. So actually, each of our virtual enterprises within the domain could report to a different LDAP server. So and now we're adding support for more, you know, like a single enterprise model with different groups and so on, where there's a top tier LDAP authentication that would potentially bind to Active Directory.
I mean, it sounds harsh, but a lot of providers are doing that, right? Especially when you're working with Keystone, because it's horrifying. The authorization portion of it is
no, we're well aware, and it's, you know, it's a pain point that our customers bring up, and we're actually working on that for our upcoming releases.
What about the failure scenario where the VSE goes away? How does the actual data and policy engine distribute databases across in order to protect in the case of a loss?
So you see, I mean, every component, it's designed to gracefully restart, right, without the bottom layer being affected, right? So we have timers that, you know, it's always the basically you have to understand how much you can afford stale information versus how much you leave it going, right?
Right.
But usually, basically, the control goes away, the forwarding plane continues to function, and also the neighbors continue to maintain the relation. Is the BGP graceful restart principles that we apply at every layer.
It's just, yeah, of course, new things can't come, but the existing policies are still active until all the controls are back.
Let's say it's, you know, ships in the night forwarding, but all the forwarding plane remains the same. The VSCs, the difference that we have with other vendors is that we have this two-tier approach where the policy is a redundant, you know, MySQL-based cluster with 3 databases and so on, and then our VSCs, which are the actual doing the flow programming and talking to a more reduced number of hypervisors, those are entirely stateless. So if that reboots, it will just request the policy again from the central controller. And also what we were talking before about this, you know, damage control radius, is that you can have, let's say, a controller every, you know, 5 racks or 10 racks worth of hypervisors. So if that controller fails and it's a redundant controller, you still have a redundant pair. But even if something happened to the rack where those controllers are being hosted and so on, you only lose this rack, but all the rest of the system remains, you know, all the interconnection between them remains. And also if the controller goes away, all the data path and the data plane remains in place until, you know, you're going to be prevented from activating new VMs into the network, but everything else stays in place.
Sorry, go ahead.
You mentioned, you know, a role-based authentication. I mean, have you thought about implementing something like the two-man, where, like, you know, he makes a change, but then I have to approve it just because it might, like, take down something?
No, so this, in general, this will be like a workflow which is above in that policy engine. That's where usually is implemented, right? The way we try to structure the roles, we try to give this like ACL or firewall rule sandwich, where you're the boss, you're dictating the top security rules. Nobody can break those. Nobody can remove those. Whatever they set in there, if you give them, you as the top guy can give them the rights to put in there additional rules, or not, if you don't trust them or if you think there is no need for that, okay? So the top guy can control it.
Yeah, I guess I was more thinking about the human error.
Yeah, so currently not so much, but something we could do based on the, we're doing a policy import and export language. So something that could be done is, for example, to edit the policy, but have it in a, you can have multiple policies and only one of those being active. So potentially you could have the right to activate a policy is only left to, let's say, the administrator. Other users could design copies of the policy, and then the activation would be done only by the administrator.
How about like an auto rollback feature? Like you implement a policy and then it breaks everything, but it'll roll back after 30 seconds.
So that's not something that we currently have.
We don't support that, but I mean, we see that's the thing. We have in here basically a policy engine that could be manipulated. The REST APIs. I mean, in the UI we try to build a model that we saw people able to monitor and design templates. The REST APIs usually have the possibility to be manipulated, And we
you
can
can actually see
expand
the diff, though, right? Like you,
Right,
you
like
actually
you
have
get
you
the
can export the diff, and you could pull back based on that.
Potentially, you know, we're adding the capability of exporting and importing all the policies into, let's say, a plain text or JSON file, so you could do a diff between both policies.
Yeah, and restart
and you know, re-import the old policy if needed, or just work with multiple active policies. So you activate one, and you know, it's a bit different than what would happen in a regular router where you logged in, and when you change the policy, suddenly you kicked yourself out, and that's why you have this automatic rollback 30 seconds that, you know, will restore the previous network configuration. Here, we expect at least that the controller itself will, you know, will not be affected by the policies running on the DC.
The main reason for the import-export was to establish kind of a template store where you can basically build, you know, put everybody's templates in one common repository and allow them to import and reuse, right? Not for the rollback, but I mean, that could be used for the rollback.
And also the format should be pretty, you know, it's machine readable, but it's also human readable, so it could work pretty well with like a code repository tool. So you could, you know, commit them into Git or things like that, and see the diffs very easily on Git, because it would be basically a JSON of the policies. So.
What I wanted to add here, I should have mentioned it when we talk about the you know, the organization of our VSP with a brain, kind of a heart, and the way we distribute the task. We have abstracted policies at the top, and then they are pushed to the controllers, and then the controllers do the work between themselves. So, you know, there was a big problem with security groups in OpenStack when they were trying to do security group to security group rules, and the neutron brain pretty much died down when they have to push all this. The way we implemented that, just to give you an example of the advantage, right? We basically are pushing the policy groups to the virtual machines, and then we tag them and let the controllers signal who belongs to the security group. So we just need to tag a virtual machine in a security group 2, and then basically in the control plane gets the distribution of who belongs to what and the implementation instantiation of the policy group to policy group rules on the virtual machine side. So we had a test, one customer, one enterprise private cloud customer asked us to run with 65,000 VMs, where we executed basically networking bring up from scratch. We brought networking down, the VMs were instantiated, they asked us to bring them up, and we did 10 times better than the competitor, the lab competitor in there, just because of this distribution of the rules and the capability to actually group the controllers, put the controllers to work with. You know, you can do 1,000 servers or you can do 500 servers. If you want to achieve faster convergence, fast failover, you can reduce the scope of every individual controller without actually addressing the a problem in terms of scaling. Because controllers, we have like in the telco space, 2,000 controllers working together from a brain perspective, right? So it's basically scaling enough. You can actually redistribute them and let them converge faster. It's an architecture that is flexible enough to accommodate different set of requirement scope.
Well, the scale is interesting, especially in OpenStack, because we know at scale there's trouble with, you know, we all trust eventual consistency, but when you've got, you know, Nova works at different speeds than Neutron does, and there's been difficulties where it doesn't, you know, there's a longer convergence on the Nova side because of, you know, scheduler gets backed up, hypervisors can't keep up, so basically you end up trying to push policy. That's fine, policy goes out first, compute goes out second. There's occasions, not often, where the reverse would happen, where compute is alive and yet it has no policy applied to it. I mean, it's rare, but you know, what do you actually wait for?
So in our case, what will happen is that if the compute comes up, but for whatever reason there's no response from our VSD, our policy engine, the VM will not really be attached to the network. So it all like the network connectivity and the policy comes all together as part of the VM resolution event.
Yeah.
So
we did see 10 times better, like over 130, if I remember correctly, 130 VMs per second being instantiated from a networking perspective. Much better than what the OpenStack does. And I think we are out of time here.
I'm going to do one more question to make my security guy happen. Two-factor auth.
For right now, for login, not yet. For user logins, not. We are doing some two-factor authentication for some device activations, but not yet for user login.
Perfect.